Lesson 7-3, Rational Exponents. In this video, you will learn to evaluate and rewrite expressions involving rational exponents and solve equations involving expressions with rational exponents. Your vocabulary is rational exponent, cube root, nth root, and exponential equation. Okay, so first thing we want to look at is what a rational exponent is. So if you guys remember what rational numbers are, a rational number is any number that can be written as a fraction. So like 1/3 or 2/5 or 7/8. All of these are examples of rational exponents. Anything that could be written in fraction form. So for any non-negative real number, b to the 1/2 is the same thing as the square root of b. So whenever your fractional exponent is 1/2, that's the same thing as being the square root of 16. So the square root of 16 we know is 4 because 4 squared is 16. So what we want to do here is be able to go back and forth between rational form and radical form. So radical form is the one that has that square root type symbol, and exponential form is the one that has an exponent. So this is exponential form, and we want to put it in rational form. So remember, radical form, sorry. Anything that has power of 1/2 is the same thing as the square root. So 81 to the 1/2 is the same thing as the square root of 81, which we know is 9, but this is how you would write it in radical form. Okay, now we have it in radical form, and we want to put it in exponential form. So this is the square root of 38, so we know it's going to be the same thing as 38 to the 1/2 power. Okay. Next, if we have 12m to the 1/2, we want to rewrite this in radical form, but we have to be careful about what is being raised to the power 1/2. Now, there's no parentheses around the 12 and the m, so this power of 1/2 is only being applied to that m. So this is the same thing as 12 times m to the 1/2. And that m to the 1/2 is what the square root gets applied to. So it's going to be 12 times the square root of m, or just 12 square root m. Okay. Now in this case, when we have this in radical form, the whole thing is under the radical, the 32w, which means that the whole thing, 32w, is going to be raised to the 1/2 power. So we have to put this whole thing in parentheses to show that both the 32 and the w go inside the square root. Okay, so you guys give this a try. Next thing we want to look at is the nth root. So for any real number a and b and any positive integer n, if a to the n equals b, then a is an nth root of b. So basically, if I know that a to the n equals b, then I know that nth root of b is going to give me a. So if 2 to the 4th equals 16, the 4th root of 16 will give me 2. It's like going backwards. So 2 to the 4th gives me 16. If I want to get from 16 to 2, I take the 4th root. It's the opposite. Just like we learned that the square of something is the opposite of the square root, or vice versa. So to the 4th power and the 4th root are opposites. So to the 3rd power and the 3rd root, those are opposites. Okay? So if I want to know how to simplify this, I want to know what to the 4th power gives me 256. I want to go backwards. So I'm going to just try some things. Let's start with 2. If I say 2 to the 4th, what is that equal to? So 2 to the 4th is 16, which means we need to go a little bit higher. So let's jump up. So 6 to the 4th gives me 1,296, which is way too big. So we want to go smaller. So let's try 2 to the 4th, or 3 to the 4th. 3 to the 4th gives me 81. So let's try 4 to the 4th. We get 256. When I do 4 to the 4th, I get 256. So if 4 to the 4th power, the 4th root of 256 is going to be equal to 4. Basically, it's asking what to the 4th power gives me 256. My answer is 4. Okay, here I want to know what to the 6th power gives me 15,625. So, looking at this number, this is a multiple of 5. So I'm thinking I'm probably going to want to have a multiple of 5. So I'm going to start by just first checking 5 to the 6th to see if that's what can give me that. So 5 to the 6th is in fact this number. So when this is asking what to the 6th power gives me 15,625, 5 does. So this here, the answer, when this simplifies, that is equal to 5. Okay, so you guys try simplifying these, or that one. Okay, so for any positive real number b and any integer n greater than 1, b to the 1 over n is the same thing as the nth root of b. So just like 4 to the 1/2 is the same thing as the square root of 4, if I have 8 to the 1/3, that's the same thing as the cubed root of 8. Okay, and we know that the cubed root of 8 is 2, because 2 cubed gives me 8. Okay, so I want to know what 1,331 is to the 1/3 power. So I'm going to say this is the same thing as the cubed root of 1,331. So I want to know what to the 3rd power gives me 1,331. So let's try some things again. Let's start with 4. So let's see what 4 to the 3rd power gives me. 4 to the 3rd is 64, so I have to go bigger. Let's try 6. 6 to the 3rd gives me 216. Let's go even bigger. So let's try 7 to the 3rd power. I get 434. We've got to go bigger. Let's try 9 to the 3rd power. Gives me 729. If I go 11 to the 3rd power, I get that number there. So 11 to the 3rd power gives me 1,331. So that means the cube of 1,331 is 11. Okay, same thing with this one. If this is to the 1/4 power, it's the same thing as the 4th root of 2401. And I want to know what number to the power of 4 gives that to me. So I'm just going to start putting in some things to the power of 4. I'm going to start with 6 this time. So when I put in 6 to the power of 4, so 6 to the power of 4 gives me 1,296. I have to go a little bit bigger. So let's try 7 to the power of 4. And I do get this number. So 7 to the 4th equals 2401. So when I do this, I can say this is going to be 7. Because 7 to the 4th power gives me the number. Okay, you guys try this. Okay, the next thing we want to look at is if we have a fraction where the numerator in the exponent is not a 1. So far, all the ones we've looked at, like 8 to the 1/3, we've had a 1 up here. What happens if we don't have a 1? Well, what we're going to see is that the numerator is going to be a power, and the denominator is going to be the root. Okay, so in the case of this, if we're following this rule of where this is the power, this is like 8 to the 1st power, and then the cubed root of 8. But anything to the power of 1 is just itself, so we were really only focusing on the root. However, if I had something else, like 8 to the 2/3, this is going to be the same thing as 8 to the 2nd power, and then the cubed root of that. So we know 8 squared is 64, so this is going to be the cubed root of 64. And we know that that's 4, because 4 to the 3rd power gives us 64. You could also do this reversed. You can take the cubed root first and then square it. So it doesn't matter the order you do power or root as long as you do both of them. So I can say this is the same thing as doing the cubed root of 8 and then squaring it. So here, cubed root of 8, what to the 3rd power gives me 8? It's 2. So this part in here becomes 2, and then squared, I still get 4 either way. Okay? So we want to do that with this. So I want to say, what is 32 to the 2/5? So remember, I like to do the root first because it keeps our numbers smaller. So I'm going to do the 5th root of 32, and then I'm going to square whatever I get. So remember, this is the root, and this is the power. So 5th root of 32. I want to know what number to the power of 5 gives me 32. And the answer to that is 2. 2 to the 5th power is 32. So the 5th root of 32 is 2. And then I have that square. I square it. 2 squared is 4. So when this simplifies, it becomes 4. Okay, same thing with this one. Now I have 81. This is my root, and this is my power. I like to keep my number small again because 81 to the 5th power is going to be really big. But if I take the square root first and then put it to the power of 5, it makes it a little bit easier. I know the square root of 81 is 9 because 9 squared is 81. So this has become 9 to the 5th, and 9 to the 5th is 59,049. So 59,049. Okay, next thing we want to look at is the power property of equality, which says that if you have any two numbers with the same base and raised to an exponent, then if you have the same base and those two things are equal to each other, then those exponents have to be equal. In this case, x has to be 3. So if you have 4n equals 4 to the 1/2, in order for these two things to be the same, their powers have to be the same. So you would know that n also has to be 1/2. Okay, so we want to use that concept and look at something a little bit more complicated. So I want to be able to get this to be the same base. So I want to know, okay, is there a way I can do 9 to a certain power and get 729? So I'm going to try 7 to the 3rd, and my first try, I got it. Okay, so 7 to the x equals this here, 9 to the 3rd power is 729. So this I can say, since this is equal to this, I can say that this here is 9 to the 3rd. Now I have the same base, so their exponents have to be the same. So I know that x is 3, and that's my solution. Okay, this one, is there a way I can get 8 to get to 16 or 16 to get to 8? I can't. So I want to look at the different possibilities between 16 and 8 where I have the same base. So I know 16 is 4 squared. Can I do 4 to a power to get to 8? No. So I have to go smaller than 4. I can try 2. So 2 to the 4 is 16. So I can say instead of this being 16, I can say that's 2 to the 4th. And then instead of 16, it's still raised to the 2x minus 1. And then I want to say, I want to get 8 to also be the same base as 2. I know that 2 to the 3rd power is 8. So I can say instead of 8, this is 2 to the 3rd. Now I have the same base. So I just want to simplify this. Remember, a power to a power you multiply. So this is going to be 2 to the 4th times 2x minus 1 equals 2 to the 3rd. So we're going to use distributive property here, and we get 2 to the 8x equals 2 to the 3rd. Now I have the same base. I want to set my exponents equal to each other because this has to be equal to 3 in order for these to be the same thing. So 8x minus 4 equals 3. I'm going to do plus 4, and I get 8x equals 7. So x equals 7 over 8. Okay. The population P of a culture that begins with 40 bacteria and doubles every 8 hours can be modeled by this, where T is the time in hours. Find T if P equals 20,480. So all I'm going to do is put in 20,480 equals 40. 2 times 2 to the T over 8. So what I want to do is I want to be able to solve for this and get basically the same thing on both sides. I'm going to divide both sides by 40. If you guys want to go through and try this, you're welcome to. I don't have enough time in this video to do it. We'll do it in class tomorrow. So we're going to stop our video with one more problem. Well, no, just kidding. We're going to stop there. Okay.